Hello everyone. Today we'll discuss about complement of a graph. So what is complement of a graph? So this is the definition of complement of a graph. So first of all, we will take a simple graph with any vertices or with n number of vertices, and we will find the complement of this graph. And the complement of a graph is denoted by G bar. And G and G bar has same number of vertices, and the adjacent edges in G are not adjacent edges in G bar, and adjacent edges in G bar are not adjacent in G. So these two graphs are complement to each other. So what is the definition of complement of a graph? Let G be a simple graph with n vertices. So first of all, we will find the complement of a simple graph. So the complement G bar of G is defined to be simple graph with the same vertex set as G. Same vertex set. So G and G bar has same vertex set and both are the simple graphs, where two vertices U and V are adjacent precisely when they are not adjacent in G. So U and V are adjacent in G, then U and V are not adjacent in G bar, and U and V are not adjacent in G bar, then U and V are adjacent in G. So taking this example, see, look, these two beautiful graphs. So this graph name is G and this is G bar. So this is a complement. G is complement of G bar. So how to draw a complement of a graph? See this graph, A, naming the vertices A, B, C, D, E, F. There are 6 vertices, and here also A, B, C, D, E, F. So number of vertices in two graphs are same. Now checking the adjacent edges in G and G bar. So here in G graph, A is adjacent with C and E. A is adjacent with C and E. So in G bar, A is not adjacent E and C, and A is adjacent with other 3 vertices, that is F, B and D. See this, A is adjacent with F, B and D. Next, come to the vertex B. B is adjacent with F and D in G bar. So here B is not adjacent with F and D, and B is adjacent with A, B and E. So in G, B is not adjacent with A, E and C. Similarly, we will find the complement of a graph. Now draw complement of this graph. There are 5 vertices and this graph is like a star. So find out the complement of this graph. So there are 5 vertices. Now we'll take same number of vertices, that is 5, and A, B, C, D, E. This is A, B, C, D, E. So check, A is adjacent with D and C. A is not adjacent. This is G graph and this is G bar. So here in complement graph, A is not adjacent with D and C, and A is adjacent with E and B. Okay. Now B is adjacent with E and D in G. So here B is not adjacent with E and D. So and it is adjacent with A and C. Say C is adjacent with A and E. So here C is not adjacent with A and E. It is adjacent with B and D. And D is adjacent with A and B. So here D is not adjacent with A and B, and D is adjacent with C and E. Now E is adjacent with B and C in G graph, and here E is not adjacent with B and C in G bar, and it is adjacent with A and D. So we will find the complement of graph G. So this graph is complement of this graph, and this is also complement of this graph. Now come to self-complementary graph. So self-complementary graph is a simple graph first. So a simple graph is called self-complementary graph if it is isomorphic to its own complement. So we have already discussed isomorphic graphs. What is isomorphic graphs? So in isomorphic graphs we are correspondence with the vertex sets and correspondence with the edge sets. One graph with another graph. So now complement graph, self-complementary graph means it is isomorphic to its complement. So these we are taking two graphs. One thing we all seen that this graph is complement of this graph. So this is G and this is G bar. They are complement to each other. Now we will see that this graph is isomorphic to this graph. So we will correspondence with the vertex set of G with the vertex set of G bar, and so taking the vertex, first vertex A, and we are correspondence A with A dash. A is correspondence with A dash. Check the adjacent with A. A is adjacent with D and C. See here, A is adjacent with E and B. So D is correspondence with E dash, and C is correspondence with B dash. Now C is adjacent with A and C is adjacent with E. So here B is adjacent with C dash and B dash is adjacent with C dash and A dash. So B is adjacent with D dash and E is adjacent with C dash. All the vertices are one-to-one correspondence. Now come to A set. E1, E2, E2, E3, next E4, E1, E2, E3, E4, this is E5. Now E1, AC is E1, AC is E1. Say here A dash, B dash is E1 dash. So E1 is correspondence with E1 dash. Now AD is E2. See AD means A dash, E dash is E2 dash. Next E3, BD is E3. So BD, that means E dash, D dash, E dash, D dash is E3 dash. Next come to E4. BE is E4. So BE. See BE is E4. C dash, D dash, C dash, D dash is E4 dash. Next E5. EC is E5. EC is E5. So B dash, C dash is E5 dash. So we will check these two graphs are isomorphic graphs and these two graphs are complement graphs. So it is complement of this graph and it is also G is isomorphic to G bar. So G is a self-complementary graph. One thing that if we take a complete graph of n vertices, then what is the complement of complete graph? That is, taking example, n is 5. Okay, n is 5. So now we'll find the complement of this complete graph. So first draw the complete graph with vertices 5, that is K5 graph. So we are taking first 5 vertices and draw the complete graph. Draw the complete graph. So this is a complete graph and it is K5 graph, and we'll find the complement of this graph. Simply this vertex is adjacent with other 4 vertices, and complete graph means one vertex is adjacent with another n-1 vertices. So what is the complement of this graph? All the vertices here adjacent to each other, and here all the vertices are not adjacent to each other. That means this is a null graph. This is complement of this graph and it is a null graph with 5 vertices. Simply you can see that only we delete all the edges and we get the complement of the complete graph. Another important part of complement of a graph is, let G be a simple graph with n vertices and G bar be its complement. So for each vertex B in G, degree of V with respect to G plus degree of V with respect to G bar is always n-1. N is number of vertices here. So taking these two graphs, G is complement of G bar, we are check this rule. So number of vertices is here 5, that is n is equal to 5. So degree of each vertex here A, B, C, D, E, and here A, B, C, D, E. So degree of this is G, so we'll check here D of A with respect to G plus D of A with respect to G bar is equal to D of A in G is equal to 2 and here that is 2. So 2 plus 2 is equal to 4, that is n-1. So for each vertex in G, degree of V with respect to G plus degree of V with respect to G bar is equal to n-1. So in all graphs you will check this point.